Section 4.6 is on inverse trig functions. So the first thing that we're going to do is we're going to talk about deriving these inverse trig functions. We have learned and talked about to find an inverse trig function, you switch your x and y. So I took the sine function and I graphed it, and I wrote down 5 of the ordered pairs that come from this graph. Now if we follow the rules and we switch x and y, we have our 5 ordered pairs. Now the problem is this is not a function. So we previously talked about the inverse trig functions, and for sine, you have 2 choices. You can write the arc sine, or you can write the inverse sine. They both mean the same thing. They're both interchangeable. You can do it either way. It does not matter. So if we look at a graph of this, and we can graph these points and we can plot these points, we can plot the inverse, but what ends up happening is on this traditional graph paper, this is in radians and this is in units, but we need to switch that, okay? So I'm gonna make this 1, 2, 3, 4, and so on, and then this would be -1, -2, -3, and so on. And if you want to use our traditional graph paper that we have posted, you can use that, or you can white it out, or you can find your own. It doesn't matter. And this is going to have to be in radians. So I'm going to do, this will be pi and 2 pi, and this will be -pi and -2 pi. So when I go to plot these points, 0, -pi, 1, -pi halves, 0, 0. Oh, this was a -1, -pi halves. My bad. 0, 0. 1 pi halves and 0 pi. And so we can see, if we keep on going, that you're going to have that sine curve. Now this is a little bit tighter because this was done, the other graph was done at a larger increments. But if we graph this, you can see that it's not a function. It does not pass the vertical line test, okay? So what we end up doing is, across the board, all of the domains of your sine, cosine, and tangent functions get restricted so that those functions are indeed one-to-one functions. They pass the vertical line test and they pass the horizontal line test. So that brings me to the handout that I gave you. And if you lost it or you don't have one, it's posted online. So traditionally, the sine function, the domain is all reals. So it's going to be restricted from -pi halves to pi halves. So if I take my graph and I restrict it from -pi halves to pi halves, I'm only going to have this piece of my sine function, which now will be one-to-one. It'll pass the vertical line test and it'll pass the horizontal line test. So as a result, my range is only going to go from -1 to 1. Now remember that when you find the inverse function, you can also switch the domain and range. So that's what happens for our inverse sine function. The range becomes the domain becomes the range. So for the inverse trig function, this right here, x is your ratio and y is your angle. So here, sine of x, x is your angle, this is the ratio. And then vice versa, this is going to be your ratio, this is going to be your angle. So my domain for sine, inverse sine, is from -1 to 1, and then my range is going to be from -pi halves to pi halves. So on my inverse trig function, it's going to go from -1 to 1 and -pi halves to pi halves. And so I'm only going to have this little piece of my graph, and that's it. There aren't going to be any arrows. These graphs are very small, simplistic. Cosine gets restricted a little bit different. The reason is, if you remember, where are sine, cosine, and tangent positive and negative? So if we did the same thing, cosine is positive in quadrants 1 and 4. That's what this is looking at for sine. Sine is positive in quadrant 1, but negative in quadrant 4. So cosine we have to switch a little bit because cosine is positive in both quadrants 1 and 4. So we can't restrict it in the same way. So that's for cosine gets used quadrants 1 and 2. Cosine is positive in quadrant 1 and negative in quadrant 2, so it covers all your bases. So then we swap. Notice again, this is going to go from -1 to 1, and then 0 to pi for your inverse cosine. Tangent, we get to go back to -pi halves to pi halves. Now notice, for sine, this is equal to, because the sine of pi halves is 1, and so it exists. The tangent of pi halves does not exist, it's undefined. So this is not in our domain, in our restricted domain. So then we swap them for our inverse tangent. And so our domain is all real numbers, and our range goes from -pi halves to pi halves. Tangent has vertical asymptotes at pi halves and -pi halves. Inverse tangent is going to have horizontal asymptotes at -pi halves and pi halves. And we will graph these here shortly. Now again, remember, inverse sine, arc sine, you can write it either way, doesn't matter. If a problem is presented this way and you switch it or vice versa, it does not matter.